Good morning, all. I am Sivagovind Nandamuri. I am teaching antenna and wave propagation subject. Today, our topic is Introduction to the Antenna and Wave Propagation. Let us look at into the first unit of the syllabus. This is the first unit of the our subject antenna. The first unit is antenna fundamentals. In this one, we have introduction and radiation mechanism, a single wire and two wire dipoles, and current distribution. And next one is antenna parameters like this, and some problems regarding this antenna parameters. So this is our first unit. So let us look at into the today. Uh, we have discussed some topics in this one, that is antenna fundamentals, like the different types of definitions in antenna, and different types of antennas, and what are the applications of the antenna, and how the radiation mechanism takes place in antenna, that is how the electromagnetic waves are detached from the antenna. Let us look at all these things right now. So the types of the antenna. Here we may find some types of antennas, like a dipole antenna, loop antenna. Based on the physical structure of these things, we can name so and so antennas. So the first one, the most popular thing is a dipole antenna. A dipole means it is a two polarities. So one is like if it is a positive pole, and if it then it is a negative pole. If it is a positive one, and upper one is a negative one. So a dipole antenna, it is made up of two straight wires or conductors. And second one is a loop antenna. It consists of a single wire, and but it turns off many wire, forming a loop like this. So these types of antennas, whether it is a dipole antenna or a loop antenna, the center is fed to a source. This source may be a voltage source, or some a transmission line, or some waveguide, some other thing. So and next one, we will look at into the next one. Based on the structure of this one, we can name it the pyramidal horn antenna. So it is a pyramidal horn antenna. And next one is a parabolic antenna. So this is the parabolic antenna is like this. So we can define an antenna in different ways. One of the most popular one, a antenna is a metallic device, is used for radiating or receiving radio waves, is called an antenna. Again, an antenna is a metallic device used for radiating or receiving radio waves, is called antenna. According to IEEE standard definitions of terms of antenna, it is defined as a means for radiating or receiving radio waves. What? It is defined as means of for radiating or receiving radio waves. Thus, here the antenna is recorded as a transmission between free space and a system used for launching an electromagnetic waves. I will look in just a few seconds. We will look at into the pictures also. And uh, actually, the electric charges are the sources of electromagnetic fields. We know all these things. We know this one very well, because previous semester which we gone through the electromagnetic waves and the transmission lines. So when electromagnetic fields are sources are time varying, the electromagnetic waves propagate away from the sources, and the radiation takes place. In general, the radiation can be considered as a process of transmitting energy. So let us look at into the basic antenna model, antenna device. Let us look at this one. I will draw. Suppose like this. All of you please look at. This is the two dipoles of wave dipole. Suppose if this dipole means two polarities. What is this one? Dipole. Dipole means two polarities. Suppose if this pole is a positive and automatically this one is a negative, or if it is a positive or this one is a negative. So the between these two poles there is a center fed source is there. We can put the source here. This source may be a voltage source or some transmission or some other thing which generates some energy, so this is what we call a source. This is what we call a source, and this is what we call a transmission line. This is what we call a transmission line. So when this source excited, that is, suppose if this source is a voltage source, then automatically this dipole is excited. So automatically here there is a electric field and magnetic field is form is produced. By using a thumb rule we can find out electric field and magnetic field. So automatically some electric current and what we call magnetic fields both are produced, so that the finally the wave, the electromagnetic waves are continually producing from the dipole. So this is the basic model or basic form of the antenna. Again, this source is an voltage source. What is that? This is the most commonly used antenna. It is what we call a dipole antenna. It is made up of two straight wires. So straight wire means this one is a straight wire, or this is a pole, two straight wires, and the exciting source is kept at the center. So this is the exciting source which is kept at the center. So is in general, this what we call these lines are, this one is excited by a voltage obtained from a transmission line or waveguide or directly from a generator. So everything is like this. Suppose if we find out the loop antenna, so the center fed source is here, and if you observe the pyramidal horn antenna, the center fed is here. If you find out the parabolic antenna, the center fed is here. So every antenna is must have a some center fed source, that is which is generated or excited to the for conducting antenna and wave propagations. So this is what we call the different types of antennas. So what is a dipole antenna, loop antenna, pyramidal horn antenna or parabolic antenna? Here there are so many number of types of antennas is there, but some of the things is I put here, that is dipole, loop, pyramidal and parabolic antennas. Okay, right? Next one, yeah, radiation mechanism. Then let us look at into the radiation mechanism. Here we can describe antenna. So like again, once you please look at, this is a transmitter end. The entire this block diagram is a transmitter session, and this one again there is a receiving end also. So the same diagram we can place here also. Suppose if these waves are received with some dipole structure, and uh, this is a center fed source. Okay, again, actually basically again from this one we can define antenna by another way. Basically antenna is a metallic device which is used for radiation or receiving radio waves. So from this one we can conclude antenna is a transducer which converts radio frequency electrical current into electromagnetic wave of same frequency as that of electrical current. Suppose if you place here, if you observe this one clearly, this is a center fed source for dipole antenna. So this dipole antenna is a center fed with by a voltage source. So by exciting this voltage source, we can get some electromagnetic waves. These electromagnetic waves are uh, uh, transmission to the free space. In the free space, at somewhere, some point of the location, some point of the location, we can put another antenna. That is a receiving antenna. Suppose if it is a transmitting antenna, then this one is a receiving antenna. Then receiving antenna in this section, the receive here electrical energy is converted into some some electromagnetic energy. So what is a transducer? It converts one form of energy into another form. So here electromagnetic waves again for receiving the data. Here the electromagnetic waves is received by receiver antenna. Again the receiver antenna is fed to some source. This source is connected to some internal circuits, so that again here electromagnetic wave is converted into again electrical energy. So this is a basic structure when a complete antenna system by a transmitter and receiver antennas. So again, how can you define another way of definition? An antenna is a transducer which converts radio frequency electrical current into electromagnetic wave. So here the antenna acts as a coupling device between a generator and transmitter and free space. So there are so many definitions also there for antenna. So these are some of the definitions for antenna. You can find if you go through the different textbooks, go through the antenna and wave propagation, you may find different definitions. So some of the definitions which we encounter up to now. So the next one is a single wire antenna radiation mechanism. We will discuss and we can talk about a radiation mechanism. I think okay, where it is, a radiation mechanism. What is the radiation mechanism? Up to now, suppose uh, in the above from the above diagram, we can observe the so many parameters here: the source, the transmission lines, the electromagnetic waves, the free space. So many parameters, so many items, so many things we may found here. So one by one we discuss that leads to the describing the complete nature of the antenna. So in this one, the radiation mechanism, how the radiation is possible, that is here radiation means somewhat it's a wave propagation. That means from if the source is excited, there is a dipole structure is there. By exciting the source, the waves are generated. How the waves are enter into the free space? So for entering into the after entering into the free space, how much time it have some it exhibits the same characteristics as that at the starting point. The same characteristics here and here, or here or some other way. Is the wave generated the same characteristics, or it is changing? Here different types of scenarios is there. We will discuss one by one. So in this one, the first one is a single wire antenna. In radiation mechanism, we find a single wire antenna. So what is a single wire antenna? Look at into this one. A single wire antenna, it is just look like this. In the above, in the previous picture, we will find to one topic, that is what is that one, a source is fed with a dipole antenna, but here it is a fundamental single wire antenna. Then how the radiation is performed in this single wire antenna? The principle of radiation, there must be a time varying current. For a single wire antenna, if charge is stationary, no current is developed, so no radiation is absorbed. If again, if this single wire antenna, if just a minute, again please come in. uh, a single wire antenna, where it is, okay, here, you please look at this one. In the above picture, in the above antenna scenario, what I said, it is a two dipoles, which is the center fed. The center fed is excited with the voltage source, right? Okay, but in a single wire antenna, how the radiation takes place? That means how the wire is excited. If a charge is stationary, that means the device is like this. No current is developed, so no radiation is observed. If charge is moving with a uniform velocity, that means here also some excitation sources is there, like truncated means if you trunk the wire, there is a some excitation. And if you bend the wire, there is a some excitation. If you curve the wire, there is a some excitation. So like that, if a charge is moving with uniform velocity, then no radiation for straight wire, no radiation for straight wire. If possible radiation, if wire is curved, if it is curved or bent or discontinued or terminated, if this single wire is truncated or curved or bent, or you may alter some other way, then a possible radiation you may obtain. So this is about a single wire antenna. For a two wire antenna, the same process, maybe up or down, you can place some wire antenna. These two wires are fed to some source, a center fed source. Again, if please look at one. If the device is in ideal state, a wire, there is no charge, no current is developed. If no current is developed, no charge is developed, no radiation is observed. Then another one is, if this wire, this single wire, you may trunk or bent or terminated or some curved section, then you may find some charge, so that some current, so that you may find some radiation is observed. So this is about a single wire antenna. Suppose if you want a radiation more, you can bend the device more. So that is it is just like a loop. You may find in previous session a loop antenna. If the wire is a more number of turns, so that more number of excitation is available. If the excitation is more, the propagation is more, like that. It is a single wire radiation mechanism. Next one, it is a two wire mechanism, two wire radiation mechanism. A two wire radiation mechanism, which is shown in the diagram. Due to the charge movement, current is produced, and it produces magnetic field intensity. You see, it is a two wires is fed with a center voltage source. One is a positive and another one is a negative. One is a, if it is a positive, it is a negative. So the charge distribution due to electric field lines. Electric field lines travel from positive charges to negative charges. the magnetic field lines form the closed loops encircling current carrying conductors. I will show it another go to the paint app and I will draw this one for you. It's a better to understand very clear. It is a two-wire radiation mechanism. In the previous thing is a single wire. So here there is no if there is no charge, there is no current, there is no what we call radiation mechanism. Here by applying a suitable voltage source, automatically there is a positive and a negative polarities is there. So automatically there is some type of current is produced, so that automatically a magnetic field and current electric field is also available, so that a radiation mechanism is possible in this one. So you please observe this diagram. This is a dipole, a complete uh, from this dipole. This is a dipole. This is center fed source. If you please first observe the first picture and the third one. By applying some voltage source, suppose if it is a positive, I will draw. You please keep in mind this diagram. I will draw it a paint app right now, right. All of you please look at once. This is a simple half wave dipole antenna, a center fed with some source. Okay, okay. If it is a positive, and automatically it is a negative charge. So we may assume some time period like this. This is a time period. So for the first lambda by 4, so this is what we call lambda by 4. This is one of the wavelength, lambda by 4 at a time equal to lambda by 4. You may assume. So as per the scenario, from positive to negative, some electric current is generated, electric lines are produced. So like this is very simple thing. At the end of the diagram, you may find, you may get a complete, a clear cut about this one. So this is for a lambda by t for time period. Suppose if the time period, if the here if the source is continuously exciting, so the waveforms are automatically traveling from positive to negative. Okay, so after hitting the waves to in this pole, at next time period, that is some other lambda by 4 time period, lambda by 4 time period, these waves are reflected. Suppose if this wave is with a polarity from positive to negative applied here, the same thing is reversed here. The same thing is reversed here. That is, I may put here reverse uh, some dotted lines I am drawing here. Dotted lines. So one is a positive one, that is one is a, if it is a forward direction, after hitting this one, as the voltage source is exciting, time period is going on, then the same wave is going on to this one. Likewise, if this wave is hitting here and next one is going like this. If this wave is hitting this pole, next one is hitting pole. So that I may draw uh, these waves after some time period. These waves are completely detached. After some period, these waves are completely detached from this center fed source, like you may find. Okay, for lambda by 4. After some time, after some lambda by 4 time, again the waves are completely, it is encircling, like it is one is a positive, one negative, and like so. This is, if you please observe again, this wave hitting here, again the same will be reflected here. Okay, this is a type of this is like one arc. All of you please observe, all of you please concentrate. If you please, this is one arc. The same thing is here. So if the propagation is continue, if the excitation is continually applying, a lambda by 4, a lambda by 4, a lambda by 4, okay, so the waves are automatically after some time it is completely detached from the device. This is what we call a wireless communication. This is what we a wireless wave propagation. This is a wave propagation. Okay guys, you please observe, you please, this is about how the electromagnetic waves are detached from an antenna. Thank you for watching this video. If you please, if you have any doubts, you please call me or mail me. So in coming sessions, we may draw some very clear pictures by using some tools, XP pen tablets. So we may use that one. We are trying to develop to reach you. Thank you. Thank you very much.